So our next practical is point-to-point communication. Point communication, that means you are connected with your destination with the help of physical medium, because right now we are talking about a point-to-point connection. That means we have to communicate directly with our destination. That means we need some cables for making the connection between two devices. So we will do this point-to-point connection or point-to-point communication with the help of our software. So ENSP is a software that helps to create the point-to-point communication. So I will start the ENSP. So just wait. I'm going to start ENSP. ENSP is going to start. So this is our ENSP. Here right now we are talking about the point-to-point communication. On that means we need minimum two PC. If you want to connect point to point directly connected, can create a connection between them. So first we have to drag PC1 here and drag PC2 here and make a connection between them. We just click on the connection button and we use auto cable for the physical medium where we connect it to the destination. So here we are just going to connect. So see, we are connected with the destination. So cable that we use, that is Ethernet, and the port that is 0/01, and both side the port number is same, Ethernet 0/0/1. So right now our connection is established, but it is not started yet. So press escape key for removing this connection link. So just drag over here. Then after that, we have to start this communication or start the connection. So there is a button as a start device, or you can select this device and right click and click on the start. So right now the connection is red and now it is green. So that means our topology is active right now. So suppose we want to assign IP address to this PC1. So we just write or click on the text button and right here, suppose I want to assign the IP address for this PC 101.102.103.1. Suppose I want to assign IP address, this IP address to this PC. So now I'm just write IP address for PC2. We have to assign IP address from same class or same network. So 101.102.103.2. So this is the IP address for PC1 and this is the IP address for PC2. So our next step is to check the connection between these two devices, whether they are communicating with each other or not. So just double click on a PC1, you will see this interface. So this interface that tells the basic configuration about PC1. So first step is to assign the host name. So suppose this is our PC1 and this is the MAC address for this PC, because we need some physical address as well. So this is our system's physical address, that is MAC address. Then after that, we are having two different ways to assign the IP address. One is static and second one is DHCP. When we are talking about the static, that means we are assigning IP address manually. Or when we are talking about DHCP, that means we want to DNS that assign IP address by itself. So when we are talking about DHCP, that means our DNS that provide IP address to each device. But right now we are using static IP address. That means we want to assign IP address by manually. So we are having two different type of IP address. One is IPv4 and IPv6. So right now we are using IPv4 only. So what is the IP address for this PC? Because we know what IP address we have to assign on this PC. So that is 101, 102, 103, 1. Then after that, no need to assign any subnet mask to this PC and no need to assign any gateway to this PC because we are just talking about the communication between only two devices, that is point to point communication. So after that, after assigning IP address or after IP address, you just click on the apply button. Click on the apply button. IP address is assigned to this PC. Then if you check the IP address whether it is assigned or not, the another tab that is command prompt. Then go to the command prompt. It will first welcome to you. Then after that, how we can check the IP address on our system with the help of ipconfig command. So ipconfig is a command. It tells the IP address of your PC. So this is the IP address that we just assigned to this PC. That is 101, 102, 103.1. And this is our MAC address, or we can say that our physical address, because we have two different types of address. One is logical as well as one is physical address. Or logical address, that is your IP address, and physical address is your MAC address. So we cannot change our system's MAC address. We can change only that is IP address. So next step is to assign the IP address for PC2. So just double click over there and first assign the name of a PC, that is PC2. And same, that is, you can see here, this is the MAC address for PC2. And again, there is same way to assign the IP address, whether you are using IPv4 configuration part or whether you are using IPv6. Right now we are using only IPv4 configuration. So IP address is 101, 102, 103.2. Then same as it is, no need to assign any subnet mask, no need to assign any gateway address. Then after that, click on the apply button. So after clicking the apply button, that means your IP address is assigned to this PC. So next step is to check whether IP address is assigned or not. Click on the command button and write command IP config. See, this is your IP address in the case of IPv4 address. That is 101, 102, 103, and 2. So our next step is to check the connection, between these devices. So how we can check the connection between two devices? We are having another command, that is ping. So ping is a command that tells the whether you are directly with connected with your destination or not, or we can say that whether destination want to communicate with you or not. So how we can check the connection between two devices? We just write the ping command, ping space IP address of destination. So right now we are on a PC2. That means we have to enter the IP address for PC1. So write ping space IP address for PC1. So 101 first octet value, 102 for second octet value, 103 for third octet value, then 1 is a last octet value. then press enter key. Then we will get reply back from your destination. See, 5 packets transmitted and 5 packet received, or 0% packet loss. That means our destination is completely connected with us. So there is slightly difference between Windows command prompt and ENSP's command prompt. In the case of ENSP simulator, it sends the 5 packet to the destination. 5 packets. See, there is a 5 packet. Or in the case of Windows command prompt, it send 4 packet by default. In this case, 5 packet. In the case of Windows, okay, I'm just going to show you. So go to command prompt. So this is our command prompt for Windows. So I'm just going to send ping command to google.com. Then Google will send reply back to the my PC. So see, it sends the packets and 4 received 4 or 0% loss. That means again, when we are talking about the Windows, because our internet is working right now, or our destination is sending reply back to us. If they want to, they are agree to communicate with us. So this is our command prompt for Windows, and this is the command from our simulator. There is only slightly different. Size of packet is same in the case of whether we are talking about the Windows command prompt or whether we are talking about the ENSP simulator command prompt. So size of packet is 32 byte, both side, and just only slightly difference, that is only number of packet. In Windows, number of packets are 4. In ENSP, number of packets are 5. Other
way is same to check the IP address. Way is same to check the connection between the two PCs. So we just check the communication from PC2 to PC1. So now I just want to communicate from PC1 to PC2. So again, write command same, that is ping
3.2.
This 2 is now our destination, because right now we are on a PC1. See, this is IP address for this.
Then press the enter key. We will get reply back from our destination. See again, same 5 packet transmitted, 5 packet received, and 0 packet loss. And size of packet is same. We can change the size of packet. We can change
This number of packets with the help of different commands that we will learn later on. So our next step is to can see that we want to trace the packets.
packet capturing. We just want to check the packet capturing.
The help of Wireshark. How we can check, or how we can capture the packet between these devices. So click on a, whether you
PC1 or whether you want to click on a PC.
so just right click over there. So here is an option that is capture data. So click on the capture data. Now see, the color is changed from green to blue. That means we want to apply the packet capturing. So it will ask the firewall
How access to capture the packets in data. So this is the interface for Wireshark. So how we can see this data, and how we can see this the number of packets. So again, go to the PC2 and send again ping command to PC1. So see, the packet is transferring because we are just capturing the packet from PC2. So we just send the packet to PC1. So first, when we send the packet to PC1, so on that time our source is 101.102.103.2 because we are sending packet from PC2 to PC1. So source on that time PC2 is a source and PC1 is a destination. So it will send 10 packet. Why 10 packet? That is specifically for 5 packet is for request and 5 packet is for reply. First it will send
Sorry, first it will send the packet to the first it send the request to the destination. Then after that, it will send reply back to the destination. So after that, it will send reply back to the destination. Then same as it is when they are sending reply back, because on that time, who is a source and PC1 is a source for, because they are sending reply back to the this PC2. So on that time, PC2 is the destination. Okay, so how we can so after that, how we can check the or how we can filter out the packets. So see, there is one protocol working on that time, ICMP. Whenever we are sending ping command to the destination, sometime this question asked in the interview, when we are sending ping command, on that time, which protocol is working? So on that time, the protocol is working, that is ICMP protocol. So here, suppose I want to write ARP, then press enter key. So there is no ARP packet right now. If I want to check ICMP, and it will show the IP address. Oh, sorry, ICMP protocols packets. If I want to check the uh, FTP, again it will show blank. Why? Because right now we are not using a FTP protocol. Suppose I am going to check TCP as well.
see there is no TCP protocol working right now because we are just sending ping command to the destination. So whenever we are sending ping command, that means we are just sending ICMP protocol. Again, I am going to write ICMP protocol. Then it will show the request and reply packet for both the connection. See, there is an option that is the ICMP protocol, that is Internet Control Message Protocol. So just click on the plus button. Then it will show the complete information about this packet. Then if you want to click on a data, then it will show the length of the packet. So length of the packet, that is 32 bytes. We can check, we can say that we can check the username password as well with the help of Wireshark. If we are using Wireshark, if we want to connect Wireshark with our private network, on that time, if suppose somebody entered username or password in my PC, and after that, it will close the website.
But I started on that time by Wireshark, so you can anybody can or I can check the username and password as well with the help of Wireshark. So Wireshark that provide the facility to the user. You can you can check the username and password as well, but only HTTP's websites, not the secure website. That is HTTPS, that is secure website, secure the URLs. So in the case of HTTP, we can see the username and password as well. We cannot break the username password in the case of if our website is started from the HTTPS, it is from secure. So this is all about the point-to-point communication. So this is the Wireshark, that is specifically for the packet capturing. I'm just going to use packet capturing from PC1 as well. So I just want to click on the capture data, click on the Ethernet, you will see here color is blue. Now our packet is our packet capturing screen is completely empty. So how we can check the packet capturing? So go to the ENSP software, click on the PC1, and the write same command again, find 101.102.103.2 for PC2. Click on the enter button. So in that time, our packets transferring. So see, their packets are transferring. So you just see there is two ARP protocol in this case. One ARP that is specifically for the broadcast, and second ARP that is specifically for Huawei. That means right now we are just broadcasting the packet to the destination, and we are using Huawei software. So that is why this two protocols is additionally added. So in previous case, our total number of packets that is from 1 to 10. Here that is total number of packet is 12. 2 is specifically for ARP protocol, that is address resolution protocol, and 10 that is specifically for ICMP protocol. So this is the all information about the point-to-point communication between two devices. So if you are people are having any doubt, you can contact me. And for that, thank you, students.